Hello friends, today let's find the shortest superstring problem. Given an array of strings words, return the smallest string that contains each string in words as a substring. If there are multiple valid strings of the smallest length, return any of them. So here are two examples. If the words are Alex loves LeetCode, we can return any permutations of these three words. So how to solve this problem? Let's see another simple example. If the words are Dale loves LeetCode, the output should not be any permutation of these three words because Dale has overlap with this LeetCode. They have the DE, D the same, and Dale and loves have the same L, so the output should be LeetCode loves. That's enough because they're already Dale here. So how to think about this problem? It seems that overlap can provide some information, but the greedy algorithm doesn't work here. So can we change our view for this problem? We can treat each word as a node. Then the change from one string to another string seems like a cost, or the distance between two nodes. Then the problem becomes if we want to visit older nodes, what is the minimum cost? It's just a TSP problem, traveling salesman problem. The difficulty here is that how do we represent the cost between two strings? Let's see. The cost from string A to string B. For example, if it's Dale and LeetCode, the cost should be 7. Why? Because the first string is Dale, the second string is LeetCode, but they already have the L the same. So in order to get LeetCode, we just need an extra 7 characters, so the cost is 7. The same if the LeetCode go to Dale, then as they have the two characters DE the same, so we only need L. So one is LeetCode, the other is Dale. So the cost is just 1. How about loves and Dale? As they don't have any overlap, so the result is just the length of the second string, so that is 3. So it gives us some inspiration, that is the order matters because these are two words, but if we want to go from Dale to LeetCode, the cost is 7. But if we want to go from LeetCode to Dale, the cost is 1, so the order matters. And we actually focus on the overlap, which is the tail of the first string and the head of the second string. So based on this observation, we can build a graph first. So the graph, the node, is just the words, and the cost, based on the overlap of these two strings, we can get a cost. So that is build a graph. So how to build a graph? We look from the code view. Let's see, if the current string is Dale, the next string is LeetCode, then how do we get the overlap? We should see whether Dale is start with. This string start with Dale? No. And then we see Dale, does it start from Dale? No. Then is L, does it start with L? Yes. So that's true. So that means we should look at the first string slowly from the beginning to the end. So then we get the cost. The second step is find the shortest path to visit all the nodes. So here are some variables we need. One is called DP. It is an integer array. Parse integer array. Minimum is integer value, last integer value. Why do we need these two variables? What does that mean? The last is the very last node because we go from the first node to the end node, so we should record the path, so we have the last node. How about minimum? That means global minimum cost. We need a variable to record the global minimum cost. Here is the thing. We need the state transition from one state to another state. For this example, in this question, each string has two states. We use it, we unuse it. So that is very suitable to use a bit manipulation. So in that case, we can use for all the state, we can just use 0, 1 to represent each words, whether we have used it before. So if we have n words, the total possible states is 2 to the power of n. So what does dp state I means? That means when we reach this state, we are at the node I, and it is the shortest cost. How about path state I? That means when we reach state and the current node is I, its preceding node is this path. Why do we need it? Because we want to recover the path. So here are two important integer arrays. So here is the core algorithm. We iterate all the possible states, start from 1 to 1 left shift n, because this is when we set all the bits to 1. And we iterate all the possible ending nodes, start from 0 to n. And if the current node is unused, how do we represent it? If current state and one left shift current node, we set the current node to one other bit is 0. So we use an AND operation with the current state. If it's equal to 0, that means current node is unused. We just continue. If we already use it, we can get a previous state. That is, we don't use the current node, so we use the XO here. So we set this bit to 0, and we get a previous state. But here we should we have two cases. One is the previous state equal to 0. That means the current state is the very first state. The current node is the first node. So the dp current state current node should just be words current node dot length. We don't have any overlap with previous state. If not the case, we just iterate all possible ending nodes for the previous state, also from 0 to n. If the dp, that means when we reach previous state and ending with previous node, the cost plus graph previous node to current node is less than we reach current state and ending current node, we update the dp current state equal to path current state current node. We update it to this. If it's less than this, we update. Another thing, we should update the path current state kernel to previous node, because it is the minimum cost path. We should record its previous node. Also, as we said, we need the minimum last, and we should update it. If the current state is the last state, what does it mean is the last state? That means all the bits are set to 1. If current state equal to 1 left shift n minus 1, and the dp when we reach current state and the current node is less than minimum, we update minimum and set last to current node. So that's the core algorithm. The last thing is just to generate a result. We call it a string builder, so we call it SB. The state start from the very end because we already have the last node. So from end to start. And the previous node will just extract from the path array. So path as last, we get the previous node. If it's not the very first node, we should insert what? We should insert last substring, this part. Why? Let's see the example. If the last at the very beginning said loves, pre-note is Dale, and then we change it to last and it's pre-note LeetCode. So what should we insert in the result? We should insert OVES, not AO, because it had overlap with the del. So we only need to insert this substring. So this is the first state of the string builder. Then here they have the overlap of DE, so we just need to insert this AO. So in the end, we just insert this whole string. So this is the final result. So when not the very beginning word, we should insert a substring here. If it's the first word, we insert the whole word. So that's how we generate the result. But after we insert it, do not forget to update the state. We just XOR the AO left shift last and set last equal to pre-node. So that's the algorithm. Now let's write a code. First, we need the n, which is equal to words dot length, and we need a graph. Just the new int. Sorry, the graph will be n. So we write a build graph. Should be graph and words. And we also need a DP. DP will equal to left n shift n, and this is n, and we also need a parse. Parse will equal to left shift n and n. So and the minimum, as we want to get a minimum, so at the very beginning we set it to integer max value, and also the last we set it to -1. Also needed to initialize the parse. So for int I equal to 0, I less than n, I plus plus. Oh, sorry, it's not n. It should be parse dot length. So arrays fail pass I equal to -1. Okay, now we just check every current state equal to 1, current state less than 1, left shift n. Okay, current state increment by 1. So we should initialize it, the DP array. So arrays fail DP current state to integer max value, but in case integer overflow, we divide 2. Then for current node, start from 0, current node less than n, current node increment by 1. What's next? We want to check whether the current state. I feel we have some typo. There should be current state. So if current state and left shift current node, if it's equal to 0, if it's equal to 0, we just continue. Otherwise, we'll get a previous state, which will equal to current state XO 1 left shift current node. Okay, so we should check if pre-state equal to 0. We know the DP current state current node will equal to words current node dot length. Else, if not the case, we just iterate the pref node start from 0, pref node less than n, pref node increment by 1. If the DP pref state pref node plus graph pref node cur node is less than DP cur state cur node, then DP cur state cur node will equal to DP pref state pref node plus graph pref node to cur node. Okay. Also, the path cur state cur node will just equal to pref node. Okay. And also here, if we want to check if current state equal to 1 left shift n minus 1 and dp cur state cur node less than minimum, then minimum will equal to dp cur state cur node. Also last will be cur node. Okay, that's the core part. Then we want to generate a result. So string builder will be the result. The state will from 1 left shift n minus 1. So while s greater than 0, we generate result. We first get a pref node, which we extract from the path array. That will be s last. We check if pref node equal to -1. So have we initialized? Yeah, we already initialized the parse. If it equal to -1, or if it equal to -1, that means it's the first node. So we just insert the words to the substring. So that will be words last. If not the case, we just insert substring. So that will be words last substring. So what is the substring? It will be what is that? Let's see if it's del to we can just see this example. For this case, the last is 5, and del to loves its cost is this 4, right? We want to add this OVES to the result. So 5 minus 4 will equal to 1. So we just start from the index 1. Then we extract the substring. So that will be words last dot length minus words. Sorry, not words. It's graph. It's a cost, right? Cost pref node to last the cost. So okay, that's the substring. And do not forget to s equal to s XOR 1 left shift last, and the last will just be pref node. So in the end, return sv2 string. Okay, so we have the build graph, private void build graph. We have this graph and strings that are equal to words. So we need 2 strings. So we just iterate j less than words dot length j plus plus. So then what should we do? We check whether the words j starts with substring of the words I. So we need the index start from 0, index less than words I, length index increment by 1. So if words j starts with words I substring index, then we know the overlap from I to j will be the words j minus words I. Let's see, we do not need to memorize this. Let's see just if del to LeetCode, then the words I is del, words j is LeetCode, so we know the cost is 7, right? Because they have the same L. So we know it's start with this L. So words j is 8. 8 minus, there should be 1 here. So how do we get this 1? That will be the words I minus this index. Is that true? It's words I dot length minus index. In that case, will be words j8 minus words I dot length 3 minus index, which is 2. So yeah, that's correct. Don't need to memorize it. We just need to get it by some example. But sometimes they don't have the overlap. So if we don't have overlap, then graph ij will just be words j dot length. So how do we decide it? We need a flag boolean will equal to find equal to false. So if it has, then the found will equal to true. Do not forget to break, because once we find it, it will be the largest overlap. So we must break it. Otherwise, there is an error. I mean, it's wrong. So if not found, we do the things. If not found, we get the graph here. So that's it. Let's run the code, see whether it has some problem. Okay, so words dot length index. Okay, seems correct. Let's submit it. Thank you for watching. See you next time.